All right, well, let's look at our next situation. Pressure. This only affects gases. So when we think of it increasing, if we increase pressure, it doesn't do it to one side. It does it to the overall thing because this is always in one container. So you can only increase pressure for the whole system. So when you increase pressure, it'll shift towards the lower number of gas particles. So if we increase pressure to this example, it'll shift it to the right, increasing the pressure and therefore increasing it towards the smaller number of particles. If we decrease the pressure, it will shift to the higher number of particles. So this one has 4 particles on this side, again, gas particles. So it'll shift to the left. If we think of how this will affect the amounts, right? If we, let's say, increase the pressure, that means these 4 particles are going to squish together to make these NH3 particles. So this concentration will go up, and in order for that to happen, these need to go down. We'll be exploring more of these in some practice, but again, if we increase the pressure, it'll shift towards the lower number of particles. If we decrease the pressure, it'll shift towards the higher number of particles. All right, let's look at our next example here, temperature. Now, what state of matter does it affect? None really. It doesn't really affect them. It's changing, adding temperature to the example. So I took our previous example with concentration. So if we increase the temperature of the situation, it will shift away from the energy in the chemical equation. So we see energy is over here. So if we increase the temperature, it'll shift towards the reactants because of the fact that energy is pushing it to make more reactants. If we have a decrease in temperature, it will shift towards the side that has the heat or energy. So in this particular example, if we decrease the temperature, it'll shift towards that energy, okay, in this case to the products. Energy can be found as a product or as a reactant. You need to look at the chemical equation and where the energy is. Our next situation is a catalyst. Now, a catalyst is a little different. Without a catalyst, there's a required activation energy that we've talked about before in order to make the products. Well, with a catalyst, it lowers the activation energy from a higher amount to a somewhat lower amount. Now, what does this do with equilibrium? Which way will it shift? Well, if we think of the path from reactants to products is to the right and products to reactants is to the left, both are equally lowered. So the catalyst speeds up the forward and reverse reactions equally. So it doesn't change equilibrium at all. Not a trick question. It just shows that not everything changes based upon this shift. So let's look at this in some practice. We have our equation here. We have some amount of kilojoules up on the product side. So if we added NH3, which way would it shift? Well, it would shift towards the left. And that's because we have an increase in concentration of NH3. That's going to form more of these reactants. Removing N2. This will also shift it towards the reactants. When we have N2 removed, the forward reaction decreases because you don't have as much to react to make NH3. This breaking down stays the same, so the overall change is to the left. Increasing pressure, that'll shift it to the right, to the products. Because we have 4 particles becoming 2, that's going to increase that likelihood. As opposed to the 2 particles making 4, that won't change as much. So we have an increased pressure to the right. Decreasing temperature, this will shift it to the right. When energy goes down, there's less energy to react with the product to make reactants. The reactants to make the products are not contingent, not needed with the energy. So this overall shift will be to the right. Removal of H2, that'll shift it to the left. Once again, as this amount goes down, the forward reaction is going to slow, but the reverse reaction is not going to change. So the overall shift is to the reactant side. Decreased pressure, you probably guessed correctly, it's the opposite of increasing pressure, because when you decrease pressure, you spread things out. And when these are all spread out, these 4 particles, it's less likely for them to make the products. These 2 particles will also be spread out, but again, that change in the likelihood is going to favor it being shifted towards the reactants. Add addition of a catalyst? None. It speeds them both up. No overall change. Increased temperature, correctly so, is going to shift it to the left. Having more energy is going to have more likelihood of the products making reactants, so therefore it's going to shift towards the left. Final thoughts. We have our joke. Why did the chemical engineering professor break up with the biology professor? There was no equilibrium in their relationship. He was always right in the middle, and she was always trying to shift the balance. Go ahead and try to answer this last question. We'll talk about it in class, and I hope to see you soon. Take care. Bye-bye.